All right, so in this video, we're going to talk about how to solve equations that are quadratic. So we'll have to talk about what does quadratic mean, and then how we can solve them. And actually, this is going to be the first in a series of videos because we're going to learn a total of 3 different ways for solving quadratics, which immediately raises the question, why do we learn 3 different ways? Well, quite simply, it's because quadratics have a few issues associated with them. Issue number 1 is they don't always have solutions, which you're going to get into in this video. We're going to introduce how to know whether or not they have solutions in this video. And if they do have solutions, sometimes those solutions are really ugly, and they're hard to find sometimes. And so the reason why we have 3 different techniques that we're going to use for quadratic equations is to deal with easy, medium, and hard problems, okay? So the first technique that we're going to look at in this video is the easiest technique to use because it connects very closely with other processes and procedures that we've learned before. The next technique that we'll learn is a little bit harder, but is still reasonable. But it unfortunately only works in rare situations. And then the third technique is kind of the catch-all technique. It's a technique that never fails. It always works. And it doesn't matter what the problem looks like to start with, you're good to go. The only issue is that it's the hardest of the 3 techniques. Okay, so we're going to end up with 3 techniques altogether, and that's going to be the bulk of our material for this week. In this particular video, we're going to introduce the concept of how to solve a quadratic equation using roots. And then this video will be followed by a video that has several examples. So you'll want to make sure that you watch both of those videos before you start the first set of homework problems. And then, of course, watch the subsequent videos for the other homework problems where we're using different techniques. All right, with all of that said as a background, let's take a look at our learning objectives and let's get started. So here are our 2 learning objectives. Find solutions to quadratic equations using square roots, and then know when a quadratic equation is going to have 2 solutions, 1 solution, or no solution. Okay. Now, specifically right here, we're referring to if you're using square roots, will it have 2, 1, or 0 solutions? Okay. So that's specifically what we're looking at. One other thing that I might mention, when we talk about finding solutions at this point in our class right now, we are still dealing with the set of real numbers. So remember, from the very, very first lesson of the school year, there are different number sets. The biggest and the most common number set that we use in our class is the real number set, but there is another number set that we'll get into eventually called the imaginary or the complex number set. And that can make the way that we do these problems look very differently. But right now, at this point in our class, we're still at the point where everything is a real number. Okay, so with all of that said, let's get started looking at some problems. Okay, so first of all, let's start with the word quadratic. Okay, you're going to want to know what quadratic means because we're going to be spending a whole week talking about quadratic equations. And later in the school year, we'll talk about quadratic functions and quadratic graphs. And that word is a word that's going to come back over and over again. So quadratic is a special kind of a polynomial. And we just did polynomials a little while ago. But a quadratic is a polynomial that has a degree of 2. And remember, degree simply means the biggest exponent. So that means we're looking at an equation where the biggest exponent is a 2. That's what we're looking at. Okay, polynomial with a degree of 2. Now, with the problems that we're going to look at today, almost none of them, a couple will be, but almost none of them will be in standard form. This first method that we're going to learn, the method using square roots, that method to solve quadratic equations works best when it's not in standard form. It works best when the equation is not in standard form. Having trouble right today, equation is not in standard form. we will talk about other methods where you have to be in standard form. So remember, standard form is when it's completely simplified. There's no parentheses left. All the like terms have been combined together, and the exponents go in order from the biggest to the smallest. Okay. So the types of problems that we're going to look at today are not going to be like that. They're not going to be in standard form. Okay. So what will they look like? Well, I'll give you a quick example of what they'll look like, but we're not going to solve this one quite yet. We're going to come back to this in just a second. But it might look like something like, let's say 3 times x plus 2 squared minus 5. Okay, so that's definitely not standard form. And then it will be an equation, so it has to be equal to something. We'll make this one equal to 70. All right. So this is an example of a quadratic equation, right? The biggest exponent is a 2. It's an equation because it has an equal sign. It's quadratic because the biggest exponent is a 2. This is a quadratic equation, but it's not in standard form. And this is the type of format that we will typically work with when we're doing problems that have, or when we're going to use a square root to solve it. Okay. But we're not going to solve this quite yet. I want to start with something more basic. So we're going to come back to this. Okay, so you might not even write this down in your notes yet, but we're going to come back to that in a minute. Okay, so let's look at something that's a little bit more basic. All right, so let's imagine that there's some number. Okay, so I'm thinking of a number. Let's just play a little guessing game. I'm thinking of a number, and if I take that number and I square it, the answer turns out to be a 4. Okay, remember, squaring means I'm multiplying it by itself. So another way to write this is I could say I'm taking this number and I'm multiplying this number by itself. And the answer turns out to be 4. Okay, so the challenge when we have to solving quadratic equations is we have to figure out what these are. Now, in this particular case, you know enough math and enough times tables that you might be able to just sort of deduce what times itself equals 4. Okay, well, most of us would be able to figure out 2 times 2 equals 4, right? So maybe the number that I'm thinking of is 2. But here's the issue, and here's the trick, and here's the problem that comes into play. What if I do a -2 times a -2? Well, a negative times a negative becomes a positive, and then 2 times 2 is 4. So -2 times -2 is also positive 4. So I run into this issue of, am I thinking of a positive number or am I thinking of a negative number? And unless I give you some extra hint, you don't know. If all I simply say is that there's a number that when I multiply it by itself, it equals 4, you don't know if that is a number 2 times 2 that's positive, or if it's -2 times -2 and the numbers are negative. You don't know which unless I give you extra information. So the same is true back here, right? Because we've talked about when we studied exponents, if I take 2 and I square it, that's going to equal a positive 4. But if I take -2 and I square it, that's also going to equal a positive 4 because the negative is inside the parentheses. And we've talked about whenever we substitute, we always use parentheses whenever we substitute. And so this is both an appropriate number to think of as potentially fitting into that slot. So here's the issue that we have. If we're going to play this algebraic guessing game of what number am I thinking of, there's not enough information to know whether it's positive or negative. So in general, this is going to be a key thing for us. In general, all the answers that we come up with in this particular method of solving using square roots So for quadratic equations, or maybe I should say equations, quadratic equations. So this is quadratic, I'm scribbling out the S there. So quadratic equations solved using square roots. So I'm just going to abbreviate square root if that's okay, SQRT. But in general, all of the answers for quadratic equations solved using a square root, because remember, what square roots do is they ask the question, what number squared equals something, right? So if I were to do the square root of 4, that's asking the question, what number when I square it equals 4? And so the answer would be 2. Okay, so that's kind of what we're doing here. In general, all of our answer for quadratic equations that are solved using square roots will have a positive and a negative answer. Okay, AKA they're going to all have 2 answers. Now, I'm saying in general, because this is generally the case, but there will be a couple of exceptions. Okay, there are some exceptions, and we'll talk about that at the end of this video. Okay, but generally speaking, usually 99% of the time, the problems that we solve are going to have 2 answers, one that's positive and one that's negative. And so you might remember from other algebra classes that we just use a plus or minus sign to represent those answers. So in this particular problem back here, I could have summarized both that 2 and negative 2 worked by saying it could be a positive or a negative 2. And I could write that, a plus or minus sign. Okay, so this is a little bit of background. Basically, the point of this background is to make sure that we all realize that our answers are going to come in pairs. And in this particular homework assignment, the pairs are going to look like this, plus or minus 2, a positive or a negative. Okay, now with that said, let's get back to this example that I wrote down before. And let's talk about some steps to solve. Okay, well, you'll notice that with the way this particular problem is written, the way it's structured, it's very similar to the radical equations that we're doing last week, right? Last week, we had equations that looked like this: 3 square root of x plus 2 minus 5 equals 70, right? They're very similar. The only difference is whether it's a square or square root. So the technique that we learned will still work. Let's get the radical all by itself is what we did before. So we added 5, and then we divided by 3. And that got the radical all by itself. And then what we would do is we knew that squares canceled out square roots, so we squared both sides. So this is what we did last week. You don't need to put that in your notes today. This is what we did last week. So we squared both sides because that cancels these things out. And that left me with something that looked like this. Okay, and then I could finish by subtracting 2. So this basic principle of get the thing that we're trying to solve for, get it by itself, and then deal with it, that basic principle still works. And so that's going to be our basic set of steps. So the first thing we're going to do is we're going to take this quantity that's squared, and we're going to get that squared quantity by itself. So that's going to be step number 1. Get the squared quantity. I'm just going to put squared thing because I'm not sure I can spell quantity correctly. Get the squared thing by itself. So, okay, get the squared thing by itself. I'm pretty sure I can spell quantity correctly, but I'm lazy. That's okay. Get the squared thing by itself. So in this case, the squared thing is this set of parentheses. That's the squared thing. So there's my step number 1. I want to get that thing by itself. And we remember from before that you always start with whatever is furthest away. So furthest away is the 5. So it's a minus 5. So I'm going to add 5 to both sides. That'll cancel these out. That leaves me with a 3 times this squared thing equal to 75. So now I can get rid of the 3. So I'm going to divide both sides by 3. That cancels these out. And now my squared thing is all alone. So now I'm ready to get rid of the square, okay? Now we know from working with radicals that squares and square roots cancel each other out. This time, however, I have a square. So if I want to cancel that out, I need to use a square root. And that's what this method is all about. We're going to use square roots in every one of these problems today. So use a square root on both sides to cancel out the square. Okay, because remember, anything you do to one side, you have to do to the other. So I'm going to take the square root of both sides. Okay, so when I take the square to both sides, the square and the square root, those things cancel each other out just like before. That means there's nothing left to change this x plus 2, so it stays exactly the same. Nothing changes there because it all canceled out. I don't need the parentheses anymore because there's nothing else except for the x plus 2. So I'm just going to leave the parentheses off. And that's what happens on the left side. On the right side, the square root of 25 is equal to 5. But now here is where our little piece of trivia comes into play. I had something back here that was being squared. It was an x plus 2. But I had something back here that was being squared, and the answer was 25. So that thing might have been positive 5, but that thing also could have been negative 5. And so this is where I'm going to add in that plus or minus sign. I'm going to call this like step 2.5. Okay, this isn't really a step, but I want to make sure that we don't forget it, right? Put in a plus or minus sign. Put in a plus or minus sign. Okay, make sure you've got that there so that you don't forget about that. All right. Now remember, that means this is two different numbers. It's a positive 5 and it's a negative 5. So let's think about what that means. The next step is I'm going to subtract 2 from both sides to make these cancel. That will get my x all by itself over here. But what will it equal to? Well, if I do a positive 5 minus 2, positive 5 minus 2 is a 3. But if I do a negative 5 minus 2, negative 5 minus 2 is equal to negative 7. So see how I'm getting two answers. I'm getting two answers, 3 or negative 7. And the reason I got two answers is because this plus or minus sign changes the way I deal with this number that I'm subtracting. Okay, so that's our third and final step, is once we get rid of the square and the square root, once those cancel each other out, once we make sure we've got the plus or minus sign added in there, our final step is to finish getting the x all by itself like normal. So solve for x like normal. Okay, solve for x like normal. All right, and that becomes our process. Okay, so this is the general process of how you solve a quadratic equation. These are our basic steps, and this is the theory about why those steps are the steps that you take, like why do you have to add a plus or minus sign and things like that. So as I said at the beginning of this video, there's going to be a second video with the just examples. So make sure you watch that second video. If there's any part of this that you didn't quite understand or that you just need more examples, that's fine. But there was another learning objective. Being able to solve these, that's one learning objective. But the other learning objective was to know when there are two solutions, one solution, or no solution. Okay. And that is going to happen right at this step right here. Okay. On these two steps, if you don't catch it on one, you'll catch it on the other. But those two steps right there, that's what's going to decide if you have two solutions, no solutions, one solution. Just like it did when we were doing radical problems, right? Once we got the radical by itself, we looked to see whether or not this thing was negative. We knew radicals never gave negative answers. So we could decide if something was positive, or I'm sorry, if something had no solution. Well, it's going to be the same basic idea now. So let's say that I get to the spot where I've got this thing that's being squared whatever it is, no matter how it looks, it might just be an x, it might be an x plus 2, it might be an x minus 12, whatever. But I got that thing being squared, and it's equal to a positive number. Like, for example, x minus 5 squared equals, I don't know, 16, right? So this is an example. Okay, this is what we're going to see. This is an example of what that will look like. And what's going to happen in that situation? Well, that's exactly what we had up here. We had this thing squared equal a positive number, and we ended up with 2 answers. Okay, so this is scenario number 1, or case number 1. Case number 1. That's probably going to be the most common case we see in our class. Okay, but sometimes case number 2 happens. Case number 2 is the thing that's being squared is equal to 0. That's case number 2. So for example, maybe I have a 2x plus 3 squared equal to 0. Okay, well, now think about this. If I take the square root of 0, I can do that, right? Square root of 0, I can type that in my calculator, I get an answer. That's no big deal. Square root of 0 is just equal to 0. Okay, that's fine. We can do that. That's completely legal. But then I go and I say, well, but I need to add a plus or minus sign, right? Well, a positive 0, a negative 0, 0 doesn't get signs. 0 is just its own thing. It's the thing right in the middle. It's not positive and it's not negative. So it doesn't make sense to put signs on it, plus or minus. We just leave it exactly like a 0, which means now we're only going to get one answer because we didn't have a plus or minus sign. Now there's only going to be one answer. And then here's scenario number 3, or case number 3. The third thing that might happen is you might end up with that thing that's being squared equal to a negative number. So for example, I don't know, 3x plus 2 squared. It really doesn't matter what's in here, right? As long as it's a squared thing, it equals negative, I don't know, 4, let's say. Okay, well, this is the exact same issue that we ran into when we were doing square roots. There are no numbers that when you square them, they equal a negative answer. That never happens. Because if I do a positive times a positive, I get a positive. If I do a negative times a negative, I get a positive. Nothing times itself ever equals a negative. So if that happens, then there are no answers or no solution. At least not any real solutions, okay? Like I said, later this semester, we're going to talk about imaginary numbers. This is where the imaginary numbers will creep in. So I'm just going to put this here as like, I don't know if this is, I'm being a little too explicit for this to be counting as foreshadowing. Okay, predicting the future. This is something that will, answers are not negative, answers are imaginary. Sorry about that, imaginary. There we go. Answers are imaginary, okay? Now, at this point in our class, you don't need to know what that means. You don't need to know what imaginary numbers are or how to find them or anything else, but that is something that we'll look at later this semester, okay? Right now, all you need to know is that there are no real solutions. There are no real solutions. That's what you need to know right now. Okay, so that takes care of all of our learning objectives. We've gone through a procedure for how to solve. There was our procedure right here. We even did an example. Like I said, if you want more examples, watch the next video. There'll be plenty of examples there. And we've looked at the 3 different scenarios. What causes 2 solutions? It's when your squared thing equals a positive number. What causes 1 solution? It's when your squared thing equals 0. And what causes no solutions? It's when your squared thing equals a negative number. Okay. Now, the one last thing that I would mention is that your calculator can help you with that, because like I said, you can type in this, square root of 0 is 0, and then I can put in the opposite of 0, and notice how it's still 0. Okay. I can do, if I had the square root of, what is my example here? Square root of 16. So if I do the square root of 16, I get 4. If I put in the opposite 4, I get -4. So now I can see there is a plus and a minus. There's a plus and minus 4. With 0, when I put in the negative, I still just got 0. There's no plus or minus. And if I try to do the square root of, what did I have here? A -4, square root of -4, my calculator tells me that there's no real answer, right? The answer is non-real. There's no real answer, okay? So my calculator can help me in those different scenarios. Okay, so that's the end of this first video. Like I said, second video will have more examples. Feel free to watch that if you need them. But thank you for watching this video. Have a good one.